Assalamualaikum warahmatullahi wabarakatuh, and a very good morning, afternoon, evening, or night, depending on what time you're watching this. So my name is Nurul Iman Binti Yusuf, and I will be presenting on my project for computer architecture, which will be talking about the usage of assembly language in an RISC. So for that, I'll be using a RISC simulator. But first, what is an RISC? So an RISC, or Reduced Instruction Set Computer, is a type of microprocessor architecture that utilizes a small, highly optimized set of instructions rather than a more specialized set of instructions often found in other architectures like RISC 5 and so on. So in the project, there are three options: set A, B, or C, and I chose set A. The differences is only the mathematical equation, and for set A, it's addition first and then it's subtraction. So this is my presented program, my presented assembly language, my instruction set. So in this code, there are 4 variables, and I am assuming that the 4 variables have 4 different registers. So I have put that num A, B, and C is 0, 1, and 2, and sum is R3. So looking into the C coding, it's input, 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 addition, subtraction, output. So it's the same. Input, 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 addition, subtraction, and output. And of course, halt for stopping the program. Now, I will be running it so that I will try to do my best to explain in under 8 minutes. Now, before I continue, what is a register? So a register is a type of memory for like arithmetic or referencing memory. And here, MAR is a register, MBR is a register, CIR is also a register. But what is a main memory? A main memory is a storage component of the currently running program data. So that's why you see all these numbers. These are all the addresses for all these lines. So see, the line 0, the address is this one, see 0. So for line 1, this is the address, okay? Now, first is the PC. What is a PC? PC is a register containing the current executed instruction address. So right now, the instruction address is this one for input R0. Okay? So when it's fetched, after it's fetched, the incrementer pluses by 1, and then it points to the next one like, okay, I'm done. Next is 1, like that. But here, there's an MAR. An MAR is a memory address register, which basically temporary storage for current data address until it's executed. So the address is stored here, and therefore the PC can increase and point to the next one already, because the MAR is saying, okay, it's okay, I'll hold it. You continue doing your work, you increase. That's why. So I'm going to play it. So see, it divides into 2. It goes to the MAR. So the MAR holds the instruction address for this one, for the first one, which is 0. So the first one is here, and now it's pointing to line 1. Okay? So this one, it goes to 0, as of course, because right now is line 0. It goes to the MBR, which is the memory buffer register, which stores data transferred, basically the same thing as MAR, and it acts as a buffer, allowing the processor and the memory units to act independently. What does this mean? So this means that basically the same thing as MAR. The MBR holds it so that the memory can do whatever it needs to do, and the processor can do whatever it needs to do, while the MBR is basically like a backup saying, it's okay, I have it in case of anything. So it goes to the CIR, which basically contains the information specifying the instruction that will be performed, and the CIR is in the control unit, the CU. Control unit is what directs the operation to the memory, to the ALU, the arithmetic and logic unit, or the IO devices. Okay, so in this case, it's going to be an input. So it decodes, and you'll see here, that input. So we're going to put in 4 because that's what I want to put in. And then the input, it will go to where I specified, which is R0. Now, because the first 3 are all the same, I will be increasing the speed. But somehow it's pretty slow. It's lagging again. It had the same problem just now, but it's okay. So the first three lines of code, which is the first 3 addresses, I mean like 1, 2, and 3, the first three, these are all the same. So same explanation. Later, for the add and the sub, these are what uses the ALU, which is the arithmetic and logic unit. And the arithmetic logic unit is the unit that carries out the operations on the operand in computer instruction words. So arithmetic and logic unit, so addition, subtraction, multiplication, division, or the logic gates, basically these are all in the ALU. So now we're already in the addition part. So in the addition, same thing happens. Fun fact, the status you see here, so this is like in case, it basically tells the ALU like whether it's negative or positive, whether it's zero or non-zero. Oh wait, hold on. Okay, non-zero or zero, carry or no carry, or overflow. So it basically tells the ALU like, okay, watch out, there are flags. So this status is to tell the ALU if there are flags. Okay, so as you can see, the control unit has informed the ALU that it has to add two numbers. So in this case, it's R0 and R1, aka 4 and 5, and it's going to be adding it. Okay, it's going to add, it will become 9, and it will store in R3. So R3 will be put here. Okay, so the same thing happens for Okay, so the same thing happens for sub. I'm sorry for the speed, it's supposed to be faster. Okay, so this goes to happen for sub. It will go to sub, but the interesting part about this one is I'm putting it in the same register. That means the 9, as you can see here in R3, after it has finished subtracting, it will go to 9 and overwrite it, which is what I want, because based on the coding here, it's both instructions are together, but in an assembly language, only one instruction can be in one line. See, it has already overwritten it, so now it's 6. So now we're already at out. So at line 5 here, the control unit will tell R3 to go out into the output device. See, out. Now 6 will appear in the output device. And finally, for the last step, this is the most simplest step, it will go to the last line and it will go to the control unit, and the control unit will tell to halt, which is stop, meaning the program has finished, it has ended, and we're done basically. And that's all for my presentation. So assalamualaikum warahmatullahi wabarakatuh, and